Okay, hi everyone. We're going to start our next unit, Unit 6, and we're starting that with perimeter. And first perimeter was the distance around a figure. Circumference C is the distance around a circle, which is actually a circle's perimeter, right? If you think about the distance around it. And area A is the amount of surface area that's covered by a figure. So first let's look at a square. And since each side is the same and has a measure of S, then we know that if I want perimeter, I add up all the sides, the distance around. So that's 4 sides, and I can do 4 times S, and that gives me the perimeter. The area of a square then is length times width, right? Or we're going to start learning in this unit to call it base times height. Well, one of those measures is an S, the other measure is an S, and so that gives me an area of S squared, or S times S. Okay. Next we have a rectangle, where my perimeter, if I add up the sides, is going to be 2 L's, because this side up at the top here is an L, and then this is also a W. So I'm going to get 2 of these L's plus 2 widths, and that will give me the perimeter, the distance around. Area is just the length times the width. Or later on we're going to start calling it base times height. So length times width. Next I have a triangle. And we'll take a look at where the area formula comes from here in a couple of slides, but for right now let's look at a triangle, and the perimeter, if I add up all the sides, so A plus B plus C, add up all of those. Make sure you can see the letters. A plus the B plus the C. So the distance around all 3 sides, add them up, that's your perimeter. And my area is going to be 1/2 times the base times the height. And so the base is going to be the side where my height, and here's my height right here, my H, that's also called an altitude, we learned in an earlier unit, where the altitude is perpendicular. So right there where it's perpendicular, this would be my base. So you're looking for that side that goes from a vertex, right here, and is perpendicular at the opposite side. That side it's perpendicular to will be your base. Okay. Then we have a circle, whose perimeter is actually called circumference, right here, C. And the circumference is, you can use one of 2 formulas depending on the given information. We can do pi times diameter, or we can do 2 times pi times the radius. And we know that the diameter equals 2r. So instead of the d, we're substituting in 2 times r for the diameter if we look at this formula here. So we're just substituting 2r, and then we have pi. That's your circumference, the distance around, and the area is pi times r squared, your radius squared. So remember that we know area is a squared unit. Area is a squared unit, like length times width. This will give me, if you go back over here to the rectangle, length times width. If those are both in, say, inches, inches times inches would give me inches squared. And so that's what we get here, radius squared. Okay, let's look at the next one. We're going to do an example of finding the perimeter or circumference. We got a couple different figures here. And then the area for the following figures. So if I want the perimeter of this rectangle, perimeter, I'm going to add up all the sides. So we know that we have 12 over here and 5 over here. So that's going to be 2 12s, 2 times 12, plus 2 times 5. So 12 times 2, 24, plus 2 times 5, which is 10. So my perimeter is going to be 34 units, whatever it is, if it's inches, centimeters. If I'm just adding them up, let's say these are centimeters, and if I'm just adding up like terms, then this would be 34 centimeters. So my perimeter is going to equal 34 centimeters. Now if I want to look at area, here's my area. Area is going to be length times width. So I'm going to take that 12, that is my length, and I'm going to multiply that by 5. So we're going to do 12 times 5, and we can use centimeters. And then I know area is 12 times 5, which is going to be 60. And then units of measure, if these are centimeters times centimeters, then I'm going to get centimeters squared. And that would be my area. So there's your two answers. Perimeter is 34 centimeters, area is 60 centimeters. Let's move to the next one. We have a circle. So this is where I'm going to use the circumference. And we know that, my circumference is 2 pi r, pi times diameter, or 2 pi r. I don't have the diameter here, so I'm going to go ahead and use the 2 pi r. My circumference is going to be 2 times pi times my radius of 2.6 centimeters. Now, in standard practice, if you have decimals in your problem, then your answer can have decimals in it. If I didn't, if it was a whole number, then I'm going to want to leave this in terms of pi. And we'll get into, in this unit, a little bit more of leaving things in terms of pi. For right now, since this one is a decimal, I'm going to go ahead and figure it out as a decimal. So C equals, I'm going to do 2 times 2.6. That's going to give me 5.2 pi. Okay, and this would be a leaving in terms of pi with a decimal. And when you say leave in terms of pi, that means to leave pi in your answer. Don't go multiply it through. Now 2 pi r, 2 times pi, and r is my only unit that has a unit of measure centimeters. So this would be like adding like terms. My circumference is going to be 5.2 pi, or approximately, and the little wavy equal sign would give you the approximate. If I do 2.5 times pi, and I used the pi button, it would be approximately 16.34. And I rounded 2 decimal places. Your directions should usually tell you how many places to round to. That's circumference. And if I want the area for a circle, area, remember, squared unit. So this is the one that is pi r squared. So my area is going to be pi times r squared. So I usually take my r, 2.6, square it, and put that pi on the end. 2.6 squared. And I'm going to get that area is 6.76 pi. And this would be units squared. So since my radius was in centimeters, this is centimeters squared. Okay, 6.76 pi. Now, this is in terms of pi because I have not multiplied pi throughout the whole problem. I've left pi as the symbol, pi. So if I wanted to get the approximation like we did up here in the earlier problem, I would go ahead and do 6.76 times pi, and you can use 3.14 or the pi button. Your pi button is, you use the second and then the up arrow would give you your pi. So I'm going to leave this one in terms of pi and we'll move on. Here is my triangle. So we're going to do perimeter. The perimeter, remember, we add up all the sides. So for perimeter of this triangle, I've got a 1 plus 4 inches plus 5 inches plus a square root of 10. And these are all in inches. So remember, when I add up all of these terms, I'm adding up like terms, inches. So 1 plus 4 is 5 plus 5. That's going to give me 10. Oops. Sorry about that. It's 10. And then plus the square root of 10. Now, since 10 and the square root of 10 are not like terms, I cannot add those together. So that would be my answer, 10 plus the square root of 10 inches. Now I have to think about area for this problem. And my area is base times height. So I'm going to take a look at the base. The base is 1 inch plus 4 inches, because remember on the base I'm looking for that perpendicular. That line going to the vertex up here, that is my altitude. That's the height of your triangle, the altitude. And so my base is 5 times the height. And I have to think about what the height would be. This would be a problem since the height is, this is what I'm looking for of the triangle. I could use Pythagorean theorem to find the height. I'm looking at this right triangle right here and needing to find the height. So I could use Pythagorean theorem. Hopefully a lot of you have recognized that my hypotenuse is 5. I have one side that's 4, and so hopefully you recognize that Pythagorean triple and you can figure out what the height would be just from that. If not, you do the Pythagorean theorem. But I'm going to tell you that the height then, this would be a 3, 4, 5 triangle, and so the height is 3. So 5 times 3 divided by 2. And I should put in units. This is 5 inches, and my height is 3 inches. So I'm going to get 5 inches times 3 inches, which is 15 inches squared, and divide that by 2. So I can leave it as 15 over 2 inches squared. Depending on your problem, if it's a word problem, we can go ahead and put that in decimal if it's a word problem. A lot of times we're going to want you to leave it in fraction, but I'll go ahead and put it in 7.5 inches squared. Okay? So that is perimeter, circumference for the circle, and area for the following figures. This slide is areas of triangles and parallelograms, and these are the postulates and theorems that we look at. Postulates, and I know I talked to a lot of my class earlier on in this semester about theorems, theorems that just make sense. The postulate 24, the area of a square is the square of the length of its side, and we already know that for the area of a square. Area of congruence postulate, though. This one tells me that if two polygons are congruent, if they're congruent, they have to have the same area. Areas will be the same. So some of these will be important when we start looking at proofs. The area addition postulate, this says that the area of a region, of some region, is the sum of all the areas of non-overlapping parts. So in other words, we can break some of these figures up into manageable pieces, find the areas of the manageable pieces, and then add them all together, sum. Theorems, area of a rectangle is the product of its base times height. Well, we know that one. That's one of the formulas we learn. Area of a parallelogram is also going to be a product of the base times the height. Corresponding height, and this is going to be important right here, corresponding height, and we'll look at that when we get to the parallelogram. We have the area of a triangle. The area of a triangle is 1/2 the product of base and its corresponding height. Corresponding height, again, those are important. The corresponding height, we're talking about a perpendicular line, and we'll look at that when we get to the next section here. So finding the area of a parallelogram and a triangle formula. Here's where we get the parallelogram. And if you remember in the previous slide that theorem that said it's base times height. Well, let's take a look at this parallelogram. If I were to come in here and cut off this one little triangle and take this triangle right here and slide it over to the other side, it would fit right there. And let's color it in. So if I were to slide that piece over, so I chopped this one off and moved it over, what do I have over here? I have a rectangle. And so we know the rectangle, for a rectangle, the area is just base times height. So what I have to look at with a parallelogram then is corresponding height. So let me draw my parallelogram and I'll show you what I mean about height. Either my height is going to be this line here where I'm looking for that right angle that's going to go from one side, a line going from one side to a vertex of the other, and where it's parallel we would call that the base. And so this piece, this line right here, is going to be the height. So again, we're looking for, I keep saying parallel, we're looking for this perpendicular box right here, perpendicular. Sorry, I keep saying parallel, don't I? Perpendicular. We're looking for a perpendicular line. Now I can also look at, I'll do my best to draw you a parallelogram. If my height is not given inside my parallelogram, think back to when we had, when we were working with triangles. Sometimes the height, sometimes that height is going to be given outside, just like we had with triangles. Sometimes that height is going to be given by a line outside your parallelogram. So let me change colors here. This is my parallelogram here. That's my parallelogram. And so my height is given right there. That would be perpendicular line containing one side, which we would call the base, going to an opposite vertex, which is going to be your height. Okay, so that's my parallelogram. Let's move to the next screen, and here's a triangle. And I told you we'd look at how we find the formula for a triangle, and here's how we do it. If we take a parallelogram, and I draw a line that bisects this parallelogram, I'm going to get two congruent triangles. One on this side, one on that side, two congruent triangles. So if I want the area of a triangle, let's use a different color. Let's say I want the area of the green triangle right here. Well, I can find the area of a parallelogram, right? Which we know the area of a parallelogram is base times height. But what am I looking for here? Of this parallelogram, I'm only wanting half of it. That gives me the triangle. So we divide by 2. That's the area for a triangle, the formula. Okay, so let's look at one example here of area of a parallelogram. So here's an example. If I have a parallelogram, okay, all my students will know I don't draw very well, but I'm going to try my best. PQRS. And what we're given is not real good, but I'm going to get a line in here with a right triangle. So here's my right angle down here, perpendicular. That measure is going to be 4. We'll get a measure here of 12. PS we'll say is 6. And then I'm also going to drop a line down here. So this would be outside, and that measure is going to be 8. So depending on my parallelogram to find area, if you're going to use PS as the base, if I use PS as the base, then my area equals base, PS, right here is the base, so 6, times the height. And what I have to look at is if this is the base, then my height is going to be from that base, perpendicular line from that base. So that then becomes this part over here. This is my height then, from the line where the base is, perpendicular to the base, going to an opposite vertex. So that's going to be 6 times 8, and that's going to be 48 units squared. Remember that area is a squared unit. If I use SR as my base, then what I get is, if SR is my base, let's go to, what color haven't I really used yet? Let's use orange. So if SR is my base, here's my base now, SR right here, that's my base. So here's my perpendicular at the base. SR is my base. We know parallelograms, it's going to be 12, right? Opposite sides are congruent. So SR is going to be 12 times, now I want the height. The height is the perpendicular line that goes to the opposite vertex, from the base to the opposite vertex. So that's going to be 4. And again, 12 times 4, and that's 48. Oops, 48 units squared. Okay, area of a triangle is 48 square inches. Here's some problems from your 1.7.11.1 perimeter and area worksheet. This is from your worksheet. This is number 9. And I'm going to go back to another color. I like blue. The area of a triangle is 48 square inches. So here's my area. It's 48 square inches. Its height is 16 inches, and we want to find the base. So remember, I'll write it over here, area equals base times height divided by 2. Here's my area, 48. Plug in what you know, base times height. I don't know the base, that's what I'm looking for, so let's leave it as base times the height, which is 16, and we're going to divide by 2. Okay, now since these are all factors on the right-hand side, the base times the height divided by 2, I can divide 16 by 2 right now. So I could do the 48 equals 16 divided by 2 is 8b, and then I'm going to divide both sides by 8. And when I do 48 divided by 8, that's going to make b equals 6. Okay? The other way we could do it, and I'll go ahead and draw, let's draw over here, is that I can get rid of my fraction by multiplying both sides by 2. So I could multiply both sides here by 2, multiply this. This would get rid of the fraction. So this would be 96 equals 16b. And then, of course, I'm going to divide both sides by the 16. And I still am going to get b equals 6. Okay? So that's how we work that problem. Area of a triangle. I'm given the area. Plug in what you know. You know the area was 48. And we need to solve for b. So use your formula just the way you know it and solve for what you don't know. Find the value of x in number 10. My area is 3. I'm going to draw a line here. My area is 399 equals base, which is my x, times my height, divided by 2. Now 21 divided by 2 isn't going to be a nice pretty number, so probably what I'm going to do is multiply both sides by 2 here. And 2 times 399 is 798. So I would go ahead and do it this way. Multiply both sides by 2. That gets rid of your fraction. I'm going to get 21x, and then when I divide by 21, now I'm going to get a nice number. 798, whoops. That should be a 21 right there. And so what I get here when I divide both sides by 21 is that x equals 798 divided by 21, which gives me a nice number of 38. Remember to put on your units. Since my area was units inches squared, and I'm dividing out a 21 inches, when I divide here, I'm dividing inches squared by inches. That's going to leave me with inches. So I'm going to get 38 inches. Okay, now one of the last things we look at for pre-AP, and if you're in level, you could probably stop now. We're going to look at finding the area of an equilateral triangle. So we can use this formula for equilateral triangles only. So if all your sides are the same measure, then this is a formula we can use to try to find the area of a triangle, but only for equilaterals. So what we do, area, here's the formula, 1/4 the square root of 3 times s squared. Okay, so if I want to do that, we can simplify this to, let me go back here a little bit. I can put the square root of 3 and s squared. If I put those over 1, and I'm going to multiply by this fraction, 1/4, remember that you multiply numerators. So that's going to give me the s squared times the square root of 3 in the top. And in the bottom, I'm going to have square root of 4, I have 4 times 1, which is going to be the 4 in the bottom. So that's how we ended up with s squared times the square root of 3/4. So let's do one of these. These are at the bottom of that worksheet that you have for your homework. So if I want a side, s is your side, I'm going to do the area here of an equilateral triangle is one side squared, 10 squared, times the square root of 3/4. Now when we do these, you want to leave them in simplified form. We can leave them in fraction, but probably I don't think we need to go to decimal. 10 squared gives me 100. square root of 3 over 4. And remember that when you do 100 over 4, 100 divided by 4, that's going to give me 25 square roots of 3. Okay? If you take a look at these problems and we did it base times height, we'd find the height. And remember, on an equilateral triangle, each of these angles is 60. And so that makes this one up here 30. So I'd get 30, 60, 90s. Divide that base by 2 to get half of that triangle, and this piece would be 5. So remember that your x is 5. My height here, my altitude, would be 5 square roots of 3 because it's across from the 60 degree. And so my base would be 10 times the whole base, 10 times 5 square roots of 3, but then you're dividing that by 2. Base times height divided by 2. 10 times 5 is going to be 50 square roots of 3, and then if I divide that by 2, I'm going to get the 25 square roots of 3. So it's kind of a shortcut way of finding, for an equilateral triangle, finding the area. I'll do number 2. The area here is going to be s squared, so 6 squared, times the square root of 3, divided by 4. So if you're looking at equilateral triangles, this actually kind of can save you a little bit of time. 6 squared is 36, divided by 4. And then 36 divided by 4 gives you the 9 square roots of 3. So that's your area of an equilateral triangle. And that is it. We are done for this first 2 sections. See you next time.